a little math trick here. So we're going to learn cross product, but only to a small degree. There's a lot more you can do with cross product. So the basic idea of a cross product is we want to multiply two vectors together and get a third vector out. Okay? Now, one thing we need to remember about cross products is they're not commutative, meaning that A cross B equals C, but B cross A doesn't equal C as well. It actually equals negative C. Much the same as subtraction works that way. 5 minus 3 is 2, but 3 minus 5 is negative 2. Same kind of idea. It just flips the direction of that final vector. All right, so there's two ways that we can do this. One of them is the way we're going to use primarily, and this is if we know magnitudes and directions for our two vectors. If we have it more in component form, that's where that second one will come in handy. So the first one, our primary way, in order to find the magnitude, I'm going to go ahead and multiply the two magnitudes times the sine of the angle between them, similar to how we did work, where we found the parallel component of the force and multiplied it by the displacement. We're now going to be finding the perpendicular component of the force and multiplying by how far that force is applied from the axis of rotation. So we are going to be using this to find torque, and so it's R cross F, and so we're going to be using this cross product when we find torque. Again, we're primarily going to be doing this method where we find the perpendicular component multiplied by the R, and then we're going to use the right-hand rule. So I'm going to put an image on the screen here. So you'll see that your pointer finger is the first term, your middle finger is the second term, and the cross of those two is your thumb. And so what you can do is you can point those in their directions, and then you can figure out the final direction of our torque. There's a couple other ways to do it. That is the way that the cross product is going to show us.